Good, good evening. This is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So, today we will continue the Logit and Probit models. In the last lectures, we have just entered to the structure of regression models, where the dependent variable is dummy in nature and one or several independent variables. So, if that is the particular format, then obviously there are three different forms of the models. One is called as a linear probability model, another is a Logit models, another is a Probit model. So, that means, so the dummy dependent regression modeling is divided into three typical formats. So, linear probability models, then Logit models, then Probit models. Okay. So, this is called as a linear binary choice models, or otherwise it is linear in nature, and this is non-linear, this is non-linear, and this is non-linear. Okay. We have discussed details about the linear probability models, where we have found lots of limitations. So, that limitation can be taken care of by Logit model and Probit models. This is Logit model is a pure use of the probability distributions, and this is typically use of normal distributions. Okay, normal distribution. That means, this is basically deals with the probability density function, and this is typical deals with the normal density functions. Okay, PDF and NDF. So, I will not again go into this direction of linear probability models. I will quickly jump into the Logit model, which we have briefly highlighted in the last class. Means how we have transferred this or how we have to build the entire structure of logistic model. So, we will quickly highlight that particular issue, then we will come to a particular application, because you will get the job is very interesting, or the model is very interesting if you will apply directly to a particular problems. Otherwise, it is just like mathematical derivations, nothing else. All right. So, what you have to do? So, for Logit model specifically, we will take we will assume that P is the probability of success, okay. Then 1 minus P is obviously probability of failures. Okay. So, then we will define P equal to 1 by 1 plus e to the power minus z. So, which is nothing but e to the power z by 1 plus e to the power z. Then 1 minus P I is observed with respect to 1 minus e to the power z by 1 plus e to the power z, which is nothing but 1 by 1 plus e to the power z. Then we divide we get the we make the division P by 1 minus P, which is equal to e to the power z by 1 plus e to the power z, all divided by 1 by 1 plus e to the power z. So, this is cancel. So, which is simply equal to e to the power z. Okay. So, now what we have done, we put logarithmic, means you have to take apply logarithm both the sides, then we will put we will get P by 1 minus P is equal to z log e. Okay, z log e. So, log e is equal to 1. So, obviously, the model will be log P by 1 minus P equal to z. Okay. So, this is how the logistic model is all about. So, now what happens? So, this P by 1 minus P is called as here odd ratio. This is otherwise represented as a odd ratio. That means, this is the ratio between this is the ratio between the probability of one group, ratio between the probability of one group, and the probability of other group, Okay. It can be also other way around. So, that means, if P by 1 minus P is the odd ratio, then obviously, this P equal to odd by odds, means odd is the ratio between this odd by 1 plus odd. Okay. This is 1 by 1 plus odds. Okay. So, this is how it can be calculated. Okay. So, these are the two our target is to find out the order ratio. How will we proceed for that? Okay. So, we will directly, because here the model will be specifically log p by 1 minus p equal to z. Okay. So, z is here equal to say beta 0 plus beta 1 x 1 I. Okay. Okay. So, obviously, the model will be, complete model will be log p by 1 minus p, okay, equal to beta 0 plus beta 1 x 1 I plus u. Okay. This is simple logistic model, simple logit model, simple logit model. So, when we will go for multivariate logistic models, then obviously the function will be like this: log p by 1 minus p, okay, is equal to beta 0 plus summation beta I into x I equal to 1 to n plus u I. Okay. So, this is obviously I is here, I is here. So, this is the multivariate logistic model, this is simple logistic model. So, that means you just summarize. So, simple logistic model, this is simple logistic model is a log p by 1 minus p equal to beta 0 plus beta 1 x 1 plus u, then multivariate logistic is log p by 1 minus p is equal to beta 0 plus summation beta I x I equal to 1 to n plus u. Okay. So, you see here. So, we start with a simple logistic models. What we have to do? So, we will take the same problem. So, let y, which is starting point is y equal to, you can say having house. Okay, having house means on house. Okay, having on house, and x is equal to income of the household, income of the household. Okay. So, this is how you have to represent the structures. So, what you have to do here, we like to investigate whether people having means whether there is any connections between income levels and people having on house. So, that means whether income has an impact on having house in a particular city. So, now the way we have discussed the same problem in the case of binary choice models, it was very simple or very easy to understand, but here there is lots of complexity. For instance, what we have done in the case of binary choice models. So, we have I sample observation 1, 2, 3, 4, 5, 6, 7 like this, or we have income levels say 10, 20, 30, 40, 50, 60, 70. Okay, these are the income levels. Then we have y, which is nothing but dummy, which is having yes no situation. Okay, yes no, yes no, yes. Okay. So, this is how the structure is all about. All right. So, now what we have to do, this is y structures, dependent variables. So, we will transfer this d into 1 0 1 0 1 1 1. Okay. So, this is how the transformation is all about. So, then finally, we will integrate d upon function of x, that means d I equal to alpha plus beta x I plus u. Okay. So, this is how the structure is all about in the case of this is linear probability models. Okay. But now, if we apply logistic models, for instance, for the logistic case, so this is obviously represented as a p. Okay. P is the probability of success, then obviously we will determine 1 minus p probability of failures. So, let me put it other way. So, here I equal to 1 2 3 4 5 6 7 8 9 10. Okay. So, we will take original figures here. So, what we have discussed in the case of binary choice model. So, this is family household income. So, in the for sample size 1. So, we will take 8, then this is 16, then it is 8, then 20, then 19, then 15, then 25, then 20, then 13, then 12. Okay, so this is the sample size. Okay, so now having house, having having on house. Okay, having on house. So that means it is no, yes, no, yes, no, yes, no, yes. Okay, and then no, yes, then yes, yes, then no, no. Okay, so this is how the structure is all about. So now what we have to do, we will transfer into D. D is 0, 1, 0, 1, 0, 1, 1, 1, 0, 0. Okay, so now we are integrating this and this. This is x and this is y. Okay, so now we are regressing D upon function of x. This is our linear probability model. So now in the case of logistic models, so instead of D we will call it a P. Okay, so then we have to define 1 minus P. Okay, so 1 minus P means this is 0, this is 1, then obviously 1 minus 1 it will be 0, then this is 1 minus 0 means 1, then this is 0, this is 1, this is 0, this is 0, this is 0, this is 1, this is 1. So that means it's just opposite. Okay, this is just opposite. So now P is this much, 1 minus P is this much. So what you have to do? So we need to have a P 1 minus P. So 1 minus P means 0 by 1. So it will be 0. Then 1 by 0. This is infinitive. Then 0 by 1 0. Then 1 by 0 infinitive. Then 0 by 1 0. 1 by 0 infinitive, 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 0, 0, 0. So if it is coming infinitive, infinitive, then obviously you cannot estimate the model. So that means if we need models P by 1 minus P. Okay, so this is how P by 1 minus P equal to alpha beta 0 plus beta 1 x 1. Okay, this is, that means we like to integrate this with this. Okay, we like to integrate this with this. Okay, so this is P minus 1 minus P. So now this system is totally inconsistent, because we cannot estimate once the figures are infinite in nature. So that means the model has a limitation. So that means whatever problems we have discussed in the binary choice models, the same problem cannot be discussed in the case of logistic models, but still we can solve this particular problem in the form of a logistic function. So we have to change the structures. Okay, what you have to do? So we use here the original figures. So what you have to do? So we apply the real probability here. So what is the probability? So means probability. What is the concept of probability? Probability means the simple of the generally probability is decided by n by n, small n by capital N, means it is the individual observation by total observation. So what you have to do in this particular structures? So we have taken only n case. Okay, so now what you have to do? We will take n and then you will define the small n. Ultimately the solution can be obtained. For instance, what you have to do? So forget about individual size. So what you have to do here? So we will take a family income here. So family income is 8, 16, 8, 20, 19, 5, 19, 15, 25, 20, 13, 12. So these are the pictures are there. So what you have to do with respect to family income? So then you have a samples. Okay, so take n number of households. Okay, n number of households, say 40, then means we are taking 40 households having income level of 8. Okay, then we will take 50 household having income level of 16, then we will take 30 household income level of 8. Okay, then 20 household income level of 20. Okay, then 50, 80 household income level of 19, then similarly 65 household income is 15, then we will take 35 household income level of 25. Okay, then 60 household income level of 30. Okay, then you will find 45 household income level of 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so then another 55. This is like this 55. Okay, so this is how the this is household. So what we are doing? So that means these are all our family income structure. So, it is $8 per day, $16 per day, $8 per day, $20 per day, $19 per day, $15 per day, $25 per day, $20 per day, then $13 per day, and final $12 per day. So, that means we have taken 10 different samples. So, in the case of linear probability model, so we transfer with respect to that income level, then we ask the respondents whether they have house or not. If they have a house, yes, then we will put yes, y, then if they have not, then we will put n, then accordingly we will transfer yes to 1, then non to 0, then you will go for its as usual ordinary process of estimation. But you know, in this case, so we are getting the order ratio in infinite, means undefined. So, it cannot be possible to go for, you can say, estimation. So, what you have to do, instead of collecting data from a particular respondent, so we will collect data in a particular city. Say for instance, we will choose a homogeneous group. So, where income is say $8 per day, then you will find out there 40 persons are there. So, what you have to do, we will classify, let us say what you have to do, you add all together. Okay. So, the moment you will add all together, then obviously, so you get to know what is the total sample size here. So, out of total sample size, the moment you will get all the respondents information, so let us say 500, then you will see what are the total income variations. For instance, out of 500 respondents, your income income structure is like this. It will vary from 8 to say 25. Okay. So, either you put it in ascending order, or you put in descending order, or as usual no hard and fast rule. So, your family income is this much with respect to this sample observations. Then within this particular family income, so you investigate number of households, so those whose income level is similar lines. For instance, first case we take 40 different households whose income is 8. Okay. So, that means what we will do, so we will find out a ratio here. So, what you have to do, we will find out a ratio here called as a n I, small n I. So, that means it is nothing but 8 by 14s. Okay. Otherwise you call it p I is n by 14. This is the small n you say, and this is capital N. Okay. So, then 40 households are there. So, 8 by 14s. Okay. So, this is how you have to find out 8 by 40, then you know 16 by 50, then 8 by 13, then 20 by 20, then 19 by 58, 15 by 65, then 25 by 35, then 20 by 60, then 13 by 45, then 12 by 55. Okay. So, this is how you have to transfer this data. So, the moment you will transfer all this data, then now you will find some figures, then you will find out 1 minus p I. Okay. So, you can able to find out, because all are in a ratio format for 0 point something or 1. So, that means this particular items will vary from 0 to 1. Okay. This item particularly 0 to items, but in the case of binary choice model, so we are taking this extreme and this extreme. So, now in this particular case, so we are taking all together. So, okay. So, the different structure all together. So, then we will find out 1 minus p, then you will fill up this gap. Once you fill up this particular gap, then obviously what you have to do, then you have to find out the ratio. So, p by 1 minus p. Okay. 1 minus p, then obviously the moment you will find out p by 1 minus p, then you have to find out its log. Okay. So, log upon p by 1 minus p. Okay. So, this is how you have to observe. So, now log of 1 by 1 minus p has to be obtained. Okay. So, this is also p by 1 minus p has to be obtained sequentially. Okay. So, that means now so this is you know, this is your family income, and this is your log transformation. So, what you have to do, so now you have to integrate the log transformation with that you know, family income. So, that will give you the indications. Okay. So, that means it is yes, means it is question of yes no situation, but it is in a different format. Okay. So, that means here the structure is we ask the 40 respondents. So, 40 respondents. So, the moment you will ask the 40 respondents, then 8 persons 8 families response is that they have house. That means rest 32 families having not any house. So, that means in a particular group, homogeneous groups. So, we are investigating, or you are taking a response from 40 households, then out of 40, 8 are having you can say their family means having their house. Then we investigate 50 peoples, then out of which 16 having house. Okay. Similarly, we investigate 30, then 8 having house. Similarly, we investigate 20 people, so then all 20 people have their own house. Similarly, we investigate 50, then 19 people have their house. Similarly, we have 65, we investigate 65 group, then 15 people have their a house. Like this, we have to classify the entire structure. That means, instead in the binary choice models, you are specifically targeting one particular section of the peoples. Okay. So, then you are going but here what you have to do in that particular Logit model. So, what you have to do, you take this particular one sample, this particular one sample, this model. So, that means you will take this structure is altogether very broad in nature. Means instead of going a particular specific area or a specific small cluster, you have to go to big clusters. So, where within that cluster there is some kind of homogeneous setup. So, that homogeneous setup will give you signal for the logistic functions. Okay. So, now with this particular structure, so we have to calculate the movement of this logistic functions. All right. Okay. So, now this what you have to do. So, P generally lies between here 0 to 1. Okay. So, then obviously, the Z here will be lies between minus infinitive to plus infinitive. Okay. Or logistic function it will move from minus infinitive to plus infinitive. Okay. So, this is 0 to 1. All right. So, now what we have to do. So, it is normally the structure is that. So, logistic format is that. So, P equal to e to the power z by 1 plus e to the power z. Okay. P is the where z can be written as a beta 0 plus beta 1 x1 plus u. Okay. This is for simple models, so which we have already discussed. Okay. Because here the target is, so we like to know what is the means family income and whether they have house or not. Means our means hypothesis is that a person having higher income may have own house, and person having lower income they have not house. This is our hypothesis. So, accordingly we gather the information and you apply the particular models, that is whether binary choice model or logistic model. Then we will come to conclusion that whether it has a specific implications, or you can say means specific whether there is any linkage between this income and having household or not. Okay. So, now we find means what we have received here. So, there is a different methodological difference, and there is also sample wise different structures. So, means altogether the structure is very complicated in the case of logistics. So, to simplify that particular structure, so you have to redesign or restructure the sample size, so that it can be possible to prepare the or it can be possible to use this logistic models. Okay. So, logistic model is typically more advanced than the binary choice models, where the format is more or less in the case of binary choice model the format is 0 to 1, but in the case of logistic model. So, we are taking the various ranges of probability, that is from 0 to 1, then we are integrating with the having their income level. So, if this particular item is significant, then you can justify that family income has a substantial impact on the people's having their house or not. Okay. So, this is how you have to observe. So, in addition to Logit models, there is another model is called as a Probit models. Okay. So, in addition to Logit models, so there is another model called as a Probit model. So, what you have to do that in the case of Probit models. So, let us see here. Okay. So, what is the Probit model? Means typically Probit model is the second different structure of nonlinear response models. For instance, we have already highlighted that your dummy dependent regression modeling is basically divided into linear format and nonlinear format. Under nonlinear format, this is linear format means binary choice model, this is Logit model, and this is Probit models. Okay. So, this is typically based on the probability density function, and this is typically based on normal density functions. Okay. So, now otherwise the structure is more or less same. So, what you have to do ultimately if you integrate all these three, then the setup is like that way, the di equal to beta 0 plus beta 1 x 1 plus u. So, this is the simple models, and di equal to beta 0 plus summation beta I x I equal to 1 to n plus u. This is for multivariate models. Okay. Multivariate models. This is what a multivariate models. Okay. So, now in whatever we have discussed in the binary choice model or Logit model, so we use simple models. So, let me first highlight this Probit model in the case of a simple structure, then we will discuss another problem which is based on a multivariate models, where the response variable is very much means a dependent variable is very much categorical, or otherwise it is a dummy in nature, where other variables are completely independent in nature, and they are somewhat quantitative in nature. So, we are not mixing together, but I mean mixing means, you see in the last lectures we have discussed the setup where dependent variable is quantitative in nature and independent variable is qualitative in nature. So, we discuss one dependent with one independent and one dummy variable, then obviously one dependent with the several independent variables which are quantitative in nature, and several dummy independent variables which are totally qualitative in nature. But in this particular format, so our independent variables may be one, may be multiple in nature, but dependent variable we are discussing only one level only, because we are not touching upon the structural equation modeling. So, what we have done, so like whatever we have discussed like bivariate, trivariate and multivariate, where y is always only dependent variables. So, here also same things. So, every case your dummy variable is a single ones, so far as this particular dummy dependent regression modeling is concerned. That means, one dependent variable is there which is purely categorical in nature, or sometimes binary in nature, and in other sides. So, we have series of or you can say one independent variable. That means, every times the right hand side will be dummy, then dummy with the one independent variables, then dummy with the several independent variables, that is multiplicative models, and this is called as a simple model. So, now there are three different structures. Binary choice model can be also integrated with this case, or it can be integrated with this case. Then Logit model can be also discussed under this heads, Logit model can be also discussed under heads. Only difference is that this particular concept, even if in the case of Probit model, these two are also same. Okay. But only difference is with respect to di representation. That means, in the case of linear probability models, so di is di such that, so it will be 1 for yes situations and 0 for otherwise. Okay. So, in the case of Logit model, so this di is represented as a pi by 1 minus pi. Okay. 1 minus pi. So, this is pi by 1 minus pi, where p is represented as a n by n. This is how the constant we have to add in the case of Logit model, because if you apply 0 1 structure in this Logit model, then it will give you inconsistent setup. So, as a result, so we will take a large samples, then within large samples you have to ask 10 respondents, then you will see out of 10 respondents how is their response. So, the probability level we will find out. So, with this basis of probability levels, then you have to find out the order ratio, and that too with the help of order ratio we like to investigate the entire problem. So, now the way we have discussed this linear probability model and Logit model. So, Probit model also can be discussed in the similar fashion. So, now for Probit models, Probit models. So, we use called as a normal density function. What is this normal density function? Normal density function is represented as a normal distribution curve. So, that is nothing but 1 by 2 pi square root into minus infinity to it will start from minus infinity to e to the power minus z square by 2 dz. Okay. So, sometimes it can be like this, f inverse I is equal to, it's better it's put I here because sample observation is I. So, I is equal to here f inverse pi. So, which is equal to beta 0 plus beta 1 x 1 plus u. Here again z is considered as a beta 0 plus beta 1 x 1. All right. So, that means the particular format can be written like this way. So, that means we in other words we can put it, even if you will put in the probability shape. So, it will be like this, q inverse p or f inverse p is equal to z. Okay. So, f inverse p equal to z. So, the way we will calculate log of p by 1 minus p is equal to z. So, this is case of logistic models, Logit models. This is called Logit models. This is Logit models. It is derived from logistic function in fact. So, this is f inverse p equal to z. So, this is derived for Probit models. Okay. This is for Probit models. All right. So, now so what is p here? So, this p is functioned as a minus infinity to I or z. It is better since we are using z here. So, then it will be z here. So, 1 by 2 pi e to the power minus you can say u square by 2 u dz. Okay, or 2z dz. So, okay, this is how you have to calculate. Okay. So, that means you just make a comparison here. So, we have three different format. So, linear probability models, then Logit models, then Probit models. Okay. Probit models. So, in what is the similarity? In similarity is that, so every times the y and y is a function of x. So, here y is also function of x, here y is a function of x. Okay. So, now this is simple models, this is simple one, this is also simple one, then this is also simple one. Okay. So, now y as a function of x 1 up to x 2 up to say x k. So, this is y upon x 1 up to x 2 up to x k, then this is y upon x 1 f to x 2 up to x k. So, it is better put x 1 here, x 1 here, x 1 here. All right. So, now in the first simple setup means what is the similarity here in both the all the three cases. These three different models are typically used in the case of dummy dependent econometric modeling. Okay. So, linear probability model, Logit model and Probit model. So, similarity is that it is applied in a particular situation where the dependent variable is dummy in nature, or dependent variable is categorical or binary in nature. So, simple model is y upon x 1, so y upon x 1, y upon x 1, though the functional form is completely different. Okay. So, now this is simple model and this is multivariate models. This is multivariate model. This is also multivariate model, this is also multivariate models. So, what you have to do in the case in this particular structure? So, we will write d I equal to beta 0 plus beta 1 x 1s. Okay. So, here d categorically divided into 0 1 limit, and in this case, this particular logistic case. So, we will write log of p by 1 minus p okay, is equal to beta 0 plus beta 1 x 1, beta 1 x 1, obviously it is u here, obviously u is here. So, then this here p lies between 0 1, okay. This is also binary in number, but the range of the samples will be in between 0 to 1, okay. So, in the case of Probit models, so we use q means inverse psi inverse, okay, psi inverse p, psi inverse p, psi inverse p is equal to beta 0 plus beta 1 x 1 plus u, okay, beta 1 x 1 plus u, okay. So, this this particular length will be from it will start from minus infinity to minus infinity to z, okay. That is how the range is all about, means z is alpha plus beta x, okay. So, this is how the minus infinity to z. So, this is the total shape. So, the entire structure is like this way. So, what we have observed here, the right hand side, all the sides are very much equals, okay. So, only the difference is the left hand structure. So, that means in the case of binary choice models, so it is the simple structure. So, we will put simply di, then the transfer all the sample point into 0 0 1 binary format, and in this particular structures. So, we may transfer into 0 into 1 format, but it is going against the means the structure is going towards the inconsistent level. So, what you have to do, instead of individual sample, we will take group samples here, okay. So, the only difference is these two cases you will go for group samples, okay, group samples rather than individual samples. This is called as a individual sample case, individual sample case, okay. So, it is case of individual sample case. So, now what you have to do, we have to find out what is the speciality of these three models, okay. So, that means it is little bit advanced. The reason is that here it is little bit more complicated and advanced than this one, and this is more complicated than this one, it is more advanced. By statistical angles, this particular function is more reliable, because it is follows the normal distribution shape. If anything attached with normal distribution, then the accuracy of the model will be very high. So, that is why Probit model is better choice than the Logit model. Similarly, Logit model is better choice than the linear probability model. But out of all these three, most typical so most of the instances we like to use this Logit models, okay, because the outcome of the Logit model and the outcome of Probit model is more or less same, okay. Only difference is it is a functional format. One case we are transferring the group sample means transferring the variables into logistic function, and another case we are transferring the information through, you can say, normal distribution function. That is the only difference between a Logit model and Probit model. Otherwise, the setup is more or less same. So, okay. So, this is the simple setup which we have discussed. In the case of multivariate models, so di equal to simply beta 0 plus summation beta I x I equal to 1 to n plus u I. So, this is called as a simple multivariate models for binary choice model, okay, for simple multivariate binary, it is otherwise called as a simple multivariate binary choice, okay, simple binary choice models, or you can say that simple multiple binary choice model, okay, multivariate binary choice models, all right. So, this is where d lies between 0 and 1 limit, okay. So, similarly, in the other case we will write p by 1 minus p equal to beta 0 plus beta I x I a summation I equal to 1 to n plus u I, okay. So, this is called as a it is not a simple multivariate, rather it is it is a multivariate binary choice models, okay. So, this is called as a multivariate binary choice models, okay. So, this is called as a multivariate logistic models, okay. Similarly, what you will do, you will put this particular format z equal to beta 0 plus summation beta I xi I equal to 1 to n plus ui. It is called as a it is called as a multivariate Probit model, where p equal to minus infinity to z e to the power minus e to the power minus u square by 2 du. Okay. Obviously 2 pi square root of 2 pi is here, okay, 1 by square root of 2 pi is here. So, this is the probability normal distribution function. So, what you have to do? So, that means you see here we start with the simply you know p component probability yes no situation sorry, probability here yes no situation yes no yes like this. So, this is how the structure is starting point is this one. So, we will transfer into 1 0 1 1 0 0 1 1. Okay. So, this is how the transformation. So, now this direct transformation can be applied to this one. So, if you will directly handle this particular data with this particular setup, then it is called as a multivariate binary choice model. So, now if you will transfer p into 1 minus p, but this particular structure is insignificant. So, what you have to do in that case, you have to go by group samples, find out to total sample n, capital N, and small sample small n. Then obviously you will find the probability value n small n by capital N. So, with that particular value it will come in the ratio format. It will not exactly 0 and 1. So, it will be in between, most of the items will be in between 0 to 1. So, obviously p by 1 minus p cannot be undefined. So, in that case you can go for estimation, that means the model will be more accurate or more authentic. Okay. Similarly, in the case of Probit model, you will transport the entire data into this normal distribution shape, then once it will be transferred, then you have to regress with this particular model. So, this is how it is called as a Probit setup. Okay. So, similarly, we can write like this way also. So, the simple structure is in the case of binary choice model, multivariate binary choice model. So, we will write like this way: di equal to beta 0 plus beta 1 x 1 plus beta 2 x 2 continue plus beta k x k plus u. And similarly, in the case of multivariate logistic model, Logit models. Logit models. So, that is you know ln in fact this is I have made wrong here. So, it should be log, okay, log of this one it has to be taken log here. Okay. So, that means in the Logit case it is log of p by 1 minus p. Okay. So, it is equal to beta 0 plus beta 1 x 1 plus beta 2 x 2 continue up to beta k x k plus u. Okay. So, similarly, multivariate Probit models, in the case of multivariate Probit models. So, we will have inverse p equal to, or it will call it a z, then z equal to beta 0 plus beta 1 x 1 plus beta 2 x 2 plus beta k x k plus u. Okay. So, this is how the model is all about. Okay. So, now here the z is followed by 1 by 2 pi square root of 2 pi e to the power minus e to the power minus d square by 2 yes e to the power minus e square by 2 2 du. Okay, 2 du obviously okay, summation it is a minus infinity to z. Okay. So, this is how the probability normal distribution function is all about. All right. So, now I will just briefly highlight the exact difference between these two, that is means Logit model and Probit models. Okay. So, what we have to do? Okay. So, out of the three models, linear probability model, Logit models and Probit models, So, linear probability model is one shape and logit models and probit model is another shape. Okay. So, now we will see what is the similarity and dissimilarity between these two. Okay. Dissimilarities between these two. Okay. So, linear probability models is not so much a headache, because it is a simple structures where only the transformation is to binary form 0 1 situation, that is yes no situation, but in the case of Logit model and Probit models. So, it is not a question of yes no situation or binary numbers. So, you have to take a group samples, then you transfer these all items into some functional form with the help of some functional form, that is through probability distribution function and through you can say normal distribution function. All right. So, this is how you have to proceed. So, what is the exact difference in the case of Logit? In the case of Logit, so the probability mass function I will go by simple rule. So, this log p by 1 minus p, log p by 1 minus p is equal to beta 0 plus beta 1 x. Okay. So, this is one and sometimes what happens and in the case of Probit models, this is nothing but inverse p equal to z, then inverse z, q inverse p psi inverse p p equal to z, which is nothing but beta 0 plus beta 1 x, all right. You remember here. So, what you will do? So, this is the simple model for Logit and Probit, but you know we can build like this way. So, the model can be further modified by like this. So, log p by 1 minus p, log p by 1 minus p is equal to beta 0 plus beta 1 log x. Okay. So, this can be possible. Okay. Otherwise the same model it can be also for you know for Probit model. So, for Probit model it can be written as a either like this, okay, is equal to beta 0 plus beta 1 x, okay, beta 1 x, but in the same times you can write like this way, p equal to z equal to beta 0 plus beta 1 log x. Okay. So, this can be another format through which you can discuss this, you can say Logit model and Probit model. So, what I like to mention here is that we have three different sets of models to highlight or to discuss the dummy dependency case only. So, that means here the econometric model or regression model in a particular format where dependent variable is a proxy or it is usually called as a categorical or it is binary and others are quantitative in nature. So, if I will summarize all these details, means last 3-4 lectures which we means last couple of lectures we have discussed the dummy variable modeling. So, dummy variable modeling basically divided into two parts. One is one part is called as a dummy independent variables modeling and then called as a dummy dependent variable modeling. So, in the case of dummy independent variable modeling, then the structure is completely very simple. So, within the simples there is a little bit complexity with respect to bivariate setup and multivariate setups. So, when there is a dummy means the dependent variable is quantitative and independent variable is dummy, then you know we have a different setups where in one situation there is a one variable which is very much proxy and others are quantitative in nature, that means all these are with respect to independent variables. In other case, so we have multiple dummies and multiple independent quantitative variables, independent quantitative in nature. So, but in all the cases, so we are assuming y is dependent and which is quantitative in nature. So, there is no dummy in the left side, that means dummy is not attached with a dependent variable. So, altogether there are two situations in this first head. So, that means here dependent variable is very much quantitative in nature and all the cases it should be 1. Okay. So, one dependent variable with one dummy and one independent variable which is quantitative in nature. In other case one dependent variable which is purely quantitative in nature, and there is a series of independent variable which are quantitative in nature, and series of dummy variables, means other variables which is a binary in representation or categorical in representation, or you can say some way of classifications. Okay. So, because this particular structure, otherwise there is lots of integration in the multivariate analysis with respect to other application like discriminant analysis, conjoint analysis, etc. So, we will discuss details when there is such needs. Okay. So, in another set of another setups, so we have dependent variables, dummy and independent variables are very much quantitative in nature. We have quantitative in nature. So, what you have to do in this particular case? So, we have three different models. One is called as a linear probability models, another is called as a Logit model, and another is called as a Probit models. So, in the linear probability models, so we may have again simple one, and you have again multivariate one. Similarly, in the logistic case, you have a simple one, you have a multivariate one, and in the case of Probit model, we have again simple one or multivariate ones. So, in the case of binary choice models, when there is a simple the setup is simple, then obviously it is just like d I equal to alpha plus beta x I or beta 0 plus beta 1 x 1 I. So, here a d I is just representation of 0 1 representation. It is very simple one, but when we will go for multivariate, then d I equal to beta 0 plus summation beta I x I. So, we are assuming that all these independent variables are very much quantitative in nature, but in the dependent variable is qualitative in nature, or you can it is purely binary in a form. Okay. So, that is a linear probability model. But in the case of but here one thing is that you have to every time you have to use individual sample size, but in the case of Logit model and Probit model, so you have to go for group samples, and in that case the dependent variable is very much dummy, and you have to transfer with a particular function. So, we use logistic function for this transformation, and for that you use probability. Basically, we use probability density function for logistic model, and we use normal distribution function for the you can say Probit models, but the setup is almost all same. The way we will discuss that particular problem with respect to household income and household having house. So, this can be analyzed under binary model, Logit model and Probit models, but binary model structure is completely different, where its setup has an integration with the individual sample structure, but here in the Logit and Probit it is an attachment with the you can say group samples, but ultimately the right hand side structure is more or less same for Logit model and Probit model. Ultimately, it is in the form of function of x only. So, where x may be individual in nature or multiple in nature. So, if it is means whatever case, it is purely quantitative in nature. Only thing is in the right hand side it is qualitative in nature. So, you have to be very careful about its categorizations, or you can say its transformation. So, what you have to do? So, for Logit models, your transformation rule follows probability distribution function. So, whatever shape is there, so you have to transfer into order ratio. So, that is the ratio between probability of success to probability of failure. So, that is how you have to find out that particular item is very much important. Higher is the order ratio, higher is the relevance of the model, or lower is the order ratio, lower is the relevance model. Similarly, you will transfer this particular information to some form of normal distribution shape in the case of Probit models, but a Logit model and Probit model are more or less give this similar kind of results. So, that is why since in classroom situation it is very difficult to handle normal distribution transformation. So, it is better to go by Logit models, because means it is empirically we have investigated that there is not much difference. Its value wise is there is small difference, but so far as significance of the model is concerned, in the case of Probit model or Logit model are more or less same. So, but there is a little bit difference, still you have to find out the difference. It means for research point of view, it is better to have the or to analyze that particular problem with respect to probability distribution functions and as well as with the normal distribution function. That means, that is with the use of Logit model and with the use of Probit models. Okay. So, this is how this is all about this, you know, the structure of dummy variable modeling. So, there are two varieties, one is dummy dependent and dummy independent. So, now this particular topic is very useful for penal data modeling. So, which we will discuss in details in the next class only. So, with this we will conclude this session. Thank you very much. Have a nice day.